Welcome to Homework Lib.
Okay, so for question A, it's because the image cannot be focused in a very short distance to form on retina. And for question B, well, the relationship of the object image in the spherical refracting surface is the equation like this, which is NA over D plus NB over V, which is equal to NB minus NA over R. So NA and NB are refractive indexes of the two surfaces. And we know NA should be equal to 1.33 and NB should be equal to 1.40, okay? And D is the object distance and V is the image distance. If we speak it more strictly, V here is actually the distance from the cornea to the retina of the eyes, okay? Which is 2.60 centimeter. So R here is just the given, and R here is given as 0.71 centimeter, okay? So therefore we have D is equal to NA times VR over V times NB minus NA, which is and then minus R and B. If we plug in these values back into the equation, we have the object distance is equal to negative 3.02 centimeter, okay? And the negative sign here means that the object for the cornea must be 3.02 centimeter behind the cornea, okay? So the negative sign here doesn't mean the value is negative, it just means the direction, okay? So therefore we can determine the new object distance in the water, which is S prime, which is equal to 2.0 centimeter plus D. Because remember, we are assuming the eyeglasses are 2.0 centimeter in front of the eye. So therefore we have 5.02 centimeter as S prime. So we know this equation here, which 1 over S plus 1 over S prime is equal to 1 over F. And S here is the object distance, and S prime is the new image distance we got it from the previous calculation. And F is the focal length we're looking for, which is the focal length under water. So since we cannot see in water, so therefore the object distance is infinity since we cannot see it, okay? So we have 1 over infinity plus 1 over S prime is equal to 1 over F. So therefore 1 over S prime is equal to 1 over F. So we have the focal length is equal to the image distance, which is 5.02 centimeter. And the focal length of the the focal length of lens in the air is related to the index of refraction of the liquid, or in this case, let's say the water, which is given by the following equations, which is F equal to F prime times N minus NW over NW times N minus 1. So N here is the index of refraction of the lens, which is 1.62, and NW here is 1.33 because the water refractive index of water is 1.33. So now let's try to determine the focal length of the lens we're using on Earth. So F is equal to, actually we're looking for F prime, so I made a mistake here. So this should be F here and this should be F prime here. So we're looking for F prime. So F prime, which is the focal length we're using in our daily life instead of being underwater, is we know the focal length underwater is 5.02 centimeters, so it's 5.02 centimeter times 1.62 minus 1.33 over 1.33 times 1.62. Oops, sorry. Minus 1. And this will give us the focal length we use in our daily life is 1.77, which is the refracted index of the focal length of lens in the air, okay? So therefore this means that the conversion length is needed. Oops, sorry. So in order to see underwater, in order to be able to see underwater, you need a conversion lens. Okay, and these are the answers for this question.